is bounded by x squared plus 4y squared plus z equals 25. And the planes is x equals 2 and y equals 3. Okay. Okay. So this technically is our rectangle. So if we just draw xy plane, so those are the planes it says we're bounded by, and here is our rectangle. So it is in the same form we have it. So our rectangle is going to be from 0 to 2 and 0 to 3. So it's just a different way of giving it to you. So that part is the same. That's the easy part. The next part is you have to remember when it comes to integrating within space, you must always set it to z equals, because our format is always z equals f of xy. So the first thing we have to do is just bring this all over, set it equal to z. So z is equal to just bring this all the other side, 25 minus everything else. And now that we have that, now we can integrate however we choose, either with respect to y or with respect to x first, right? So I'll just be consistent as the equation. I'll just do y first and then x. So this would be the integral, or the double integral actually, of x on the outside and then y on the inside of our function. Like that. Okay. So now we integrate in respect to y first. So if we integrate with respect to y first, this is going to be 25y minus x squared y minus y to the third over 3. And all this is going to be evaluated from 3 and 0. So 0 just gives you 0, so it just depends on 3. So 3 times 25 is 75. 3x squared. And 3 to the third power is 27, I believe. And then 27 divided by 3 is 9. So 9 times 4 gives you 36. Okay. And then finally, putting these together, you get 39 minus 3x squared. So that's the answer to integrate with respect to y. So now we go back over here. Now we integrate with respect to x. Let's see the next here. Okay. And then again, you plug in 0 gives you 0, so it all depends on 2. So 39 times 2 is 78. Minus 2 to the third power gives you 8. So our answer is 70. Now, because we're always in rectangles for this section, there's a different type of integration we can use, makes it a little easier for ourselves if we're given a nice situation. Okay, and this situation is if we're multiplying an x and y together, we can break them apart and do each one individually. So what I mean by that is, let's suppose we only have a function in terms of x times a function only in terms of y. Okay. Where there's no like plus, let's say for plus 25 or something like that. It's just only in terms of x and only in terms of y. So therefore, if we have a region or rectangle R, we can break up the integral and do each part individually and then multiply the results at the very end. It's just sometimes easier to do so, or easier to look at because you're just doing one integration instead of two integrations at a time. Okay, so how this would work out is mostly with sines and cosines, because you can see there's a nice break between them. So notice sine of x, cosine of y, dy, and it dA. So it doesn't tell me which one you're doing first. We get to choose. And there's a cutoff right there, right? Sine of x is only in terms of x, cosine of y is only in terms of y. So we can use this nice little shortcut to do so. So remember, this is from x and y. So how this could break out is we could do the integral of 1 to pi over 2 of 0 to pi over 2 of our function sine of x cosine of y dy dx. Now, using our rule, I can break this apart, and since this is x and this is y, I can bring this here and do each integral separately. And it's sometimes just easier to guide to do. And then we just multiply the results at the very end, which is much nicer to do sometimes, right? So if we just break it apart, we'll just do each one individually. So we'll do x first, since it's left to right. So integral of sine of x is going to be negative cosine. So we'll have negative cosine of x evaluated at 1 and pi over 2. So cosine of pi over 2 is 0. And cosine of 1 is 1. We just get 1 on this side. Yep. Now we just integral this side. So integral of cosine gives you positive sine. And again, this is evaluated at pi over 2 and 0. So sine of pi over 2 is 1. And sine of 0 is just 0. So this gives us 1. So now we just multiply the results together. So 1 times 1, that gives us 1. Right, so it's just an alternative way of using this integration to help us out, just to break it up, make it look easier to the eye to see, and then you don't see there's so much stuff going everywhere. Okay. Now, sine and cosine isn't the only way to do so if we have situations like this as well. So given our rectangular region, we want to evaluate this integral. And again, notice this is only in terms of x, and is only in terms of y. And again, we only do this if it's multiplication. So this double integral, let's say negative 1 to 3 of 0 to 2 of this integral. It end up being the same thing you just did above. Like that. One sec. Let's see if that works. So this is just going to be x to the 5th over 5 times 2, evaluated at 0 and 2. So again, 0 just goes. Oh wait, what am I doing? This is a 3. Looking at the wrong one. Okay, so 3 to the 5th times 2 over 5. I got 486 over 5 minus, and I plug in -1, so that's going to be -2/5. And then negative makes it positive. So this becomes 488 over 5. And now we do the same thing for the y. So this is going to be integral. This is just going to be y to the 8th over 8, evaluated at 2 and 0. And to the 8th power, I got 32. Once I divide by 8, I get 32. And now all we just do is do this up there. There we go. Looks better. And now we just multiply. So I got 15,616 all over 5. And now the last part of this section is about average value. Now, depending on your teacher, you either went through average value in calculus or not. It's just a small little section in the calculus portion of integration. And it's not really too much useful, but it's very interesting portion, right? Average value comes into play when you go into expected value is more of it. And we'll go over expected values when we do triple integrals. But this is an interesting concept when it comes to average value of an integral. So back in Cal 1, the average value of a function was given to be this format. It's 1 over b minus a times the integral of a to b. In this case, it copies the exact same format as a double integral. The only difference is instead of dividing by b minus a, we divide by the area of the rectangle. So that's the area of the rectangle. Okay. All right. So that's the only difference. Other than that, we just do the double integration just like normally. Okay. So we want to figure out what is the average value of the function c equals x squared plus y squared minus 36 over our region R. So first, we just got to find the area of our region. And since it's a rectangle, it's just length times width. Right? So x goes from -1 to 3, and then y goes from 0 to 2. Not looking any better. So remember to find area, top minus bottom. So 3 minus -1 times right length times width, 2 minus 0. This is going to be 4 times 2 gives us 8. So that's our area. So now our integral, setup integral, is going to be integral of 1/8 on the outside. And we'll just do the same thing. We'll go y and x. So this is x, this is y. So -1 to 3, 0 to 2 of our function. Good. And now we just integrate like normally, right? So first we'll take an integral of respect to y first. So that's going to be x squared y minus y to the 3rd over 3 minus 36y, evaluated at 0 and 2. So notice 0 just goes away, so it just depends on 2. So we're going to have 2x squared minus 8 over 3 minus 72. So I ended up putting these together, and it gives me actually, yeah, that's a minus, right? Oh, this is a plus. So this is plus. Okay, there we go. So I end up putting these together, and I get something roughly like this. So now we just take the integral from -1 to 3 of x. So now notice it's not that bad. Okay, so now plug in everything. So 3 to the third power is again 3 times 3 is 9 times 3 27 divided by 3 gives you 9. So 9 times 2 is 18. Plug it into here. Notice the 3's cancel. And on the other side, this gives you negative 2/3. And on this side, it gives you a positive because negative gives you a positive. So this ends up being 190 minus, putting these together, gives you positive 206 over 3. And then don't forget you're multiplying by 1/8 at the very end. Okay. So after subtracting and multiplying by a 1/8, I get approximately, I gave it a decimal this time, 32.3, because I didn't want to put all the fractions together. Any questions there at all?